Hello everyone, we are continuing on our definite integrals. This time we are going to work on rules of definite integrals. So let's start with the first two rules. It says if a function is defined at x equal to a, then the integral from a to a fx dx is 0. Pretty simple. The second one, if my function is integrable on the closed interval a to b, then the integral from a to b fx dx is the same as negative of the integral from b to a fx dx. The convention, guys, I'm following in definite integrals is I'll always say the lower integral first and then I will say the upper integral. Now let's look at some examples here. The first example says you would like to evaluate the integral from 2 to 2 x5 minus 3x dx. Now remember, if the lower integral and the upper integral are the same, we don't even care what is the function. Automatically, the answer is 0. Let's look at the problem number 2. If the integral is from pi to pi sine x dx. Clearly, pi, guys, remember, is a number. So you're going from pi to pi. There it is. The answer is 0. It's the first rule we're looking at. Okay, now let's look at the second rule. The second rule, guys, it says if you have an integral from a to b fx dx, it is the same as minus the integral from b to a fx dx. So, now let's look at this one. The integral 3 to 0 x5 minus 3x dx. Now at this point we have not learned how to find definite integrals, but what we are given here is the integral from 0 to 3 x5 minus 3x dx is 21 by 2. So we will look at the answer given to us and apply the rule number 2 here. So you're given that from 0 to 3 to the function x5 minus 3x dx is 21 over 2. So if I flip the lower and the upper integrals according to the rule number 2, this answer is negative of 0 to 3 x5 minus 3x dx. And we are given that integral is 21 over 2. So what is the final answer? Minus 21 over 2. Okay. Now let's look at more rules. Now there are another two sets of rules. Number 3, say, and number 4. These rules says if you have two functions which are integrable on the same closed interval and k is a constant, then the functions k times f and the addition or subtraction of functions f and g are integrable on the same closed interval a to b. So the property number 3 says a to b k times fx dx is the same as you can take the k outside and then you take the integral a to b fx dx. Now property number 4 says if you're taking the integral a to b of the sum or the difference of the function fx and gx, it is the same as you are separately taking these integrals a to b fx dx and a to b gx dx and then adding or subtracting their final answers. So keeping these two, we're going to look at some examples. Now, we would like to evaluate this integral from 1 to 3 minus x squared plus 4x minus 3 dx. What are we given is, we are given the value of the function from 1 to 3 x squared dx to be 26 over 3, 1 to 3 x dx to be 4, and 1 to 3 dx to be 2. So we're giving these answers for these integrals. What we're going to do is we are going to apply property number 3 and 4 in the previous slide here. So let's look at this one first. 1, 2, 3 minus x squared plus 4x minus 3 dx. Now let's look at this integral, guys. If you look at this integral, it's a sum and difference of three terms, x squared, 4x, and minus 3. So first thing we're going to do is apply property number 4. This is the property number 4 we're going to do. Basically, we're going to separate all these three different functions. So we're going to do is 1, 2, 3 minus x squared dx plus 1, 2, 3, 4x dx plus 1, 2, 3 minus 3 dx. So what we have done here is we have applied property number or rule number 3, because we're talking rules here. So the first thing, we applied rule number over here, 4. Now, individually, we're going to go to each of these integrals and apply rule number 3. So the first one is, this is a constant multiplied to the function x squared. So we're going to take the negative out, write 1, 2, 3 x squared dx. Plus, now 4 is a constant that is pulled out, 1, 2, 3 x dx. Plus, minus 3 is the constant which is pulled out and written 1, 2, 3 dx. So here we are applying, remember, here we are doing is rule number 3. That's what you're doing here. Now, after this, we are already given the values for each one of them. Just plug it, get the answer. So minus 26 over 3 plus 4 times 4 minus 3 times 2. Okay, so this is going to be negative 26 over 3 plus 16 minus 6. So minus 26 over 3 plus 10 and then 30. So it's going to be 4/3. Okay, now let's look at the final rule, and it is a very, very important rule. It really makes our life very simple. What this function says if your function is integrable on the interval a, b, c, oh, we need to remove, this was a typo, fx dx, and it is integrable on 3 closed intervals. In other words, let's look at this graph. So this is my graph. I have intervals a to c, c to b. So my function, it says, is integrable from a to c and c to b. Then we can basically, it's the area under the curve. So the total area is the same as you find out the area from a to c, and then you find out the area from c to b. That's what it says. Very, very helpful, guys, when we have problems where, you have some kind of discontinuities. That way we can easily find our integrals. Remember, integration is area. Okay, now let's look at evaluate this definite integral minus 1 to 1 absolute value of x dx. Given that minus 1 to 0 minus x dx is half and 0 to 1 x dx is half. What I'm going to show to you first of all, guys, over here is how do you look at absolute value of x. Now remember, this is equivalent to x when x is greater than or equal to 0 and minus x when x is strictly less than 0. Now let's actually draw the graph, because you'll be able to see why I've got half and half. It's like finding the area using geometric formulas. Okay, so let's look at this one. So it says when x is greater, but remember this minus 1 to 1. So when I want to find the graphs, I would like, what is the value? Now if you remember, absolute value of x looks like this, right? It's a V shape. We all know that. So we like to know from minus 1 to 1. So if it is minus 1 and it is 1. Now we are looking at the area under the curve between minus 1 to 1. So when it is minus 1, we know the value is 1. Now let's look at this one. Absolute value of minus 1 is what? Because this is your function f of x. Remember that. Is 1. That's 1. Do you see this one? here. Similarly, absolute value of x when x is 1 is 1. And so this is the area under the curve. So this one, guys, is 1. This is the point 1 and this is the point 1. Do you see that? Okay, so now let's look at this. This is a nice little triangle. Do you see this one? So when you're looking at this triangle, what is the area under this triangle? So this area, so this one, minus 1 to 0. You see this one? Minus 1 to 0 and then 0 to 1. That's why we have to have that one. Because when you look at this one, this is how a V looks like. That's the graph of the curve. So of the function, absolute value of x. Now, so when I'm looking at this curve, what do we notice? First one is when this curve, the graph actually goes from minus 1 to 0 and 0 to 1. So what are we going to have? So this is the area under minus 1 to 0. What is this? Is a triangle. Do you see this one? The triangle say A, B, C. So this expression from minus 1 to 0 minus x dx is nothing but area of triangle A, B, C, which is what? Half base into height. Okay, now what is base? Base is, remember, it is the distance we're talking. So it's not negative 1, it is positive 1. Be very, very vigilant and careful. So it's half of 1. Now the height is 1. So the final answer is a half. Similarly, the area of from 0 to 1 x dx. Now here it is going to be, say, this one is, I'm going to use a different marker, area of the triangle, say, so this is B, C, and K. So B, C, and K. Again, it is half base into height. Base is 1, height is 1. So the answer is half. So now if I want to find the area from minus 1 to 1, absolute value of x dx, it's what? It's half plus half, which is equal to 1. So area, remember, square units. You can write square units. Because we do not know what the units are. We're just saying square units. Okay. Let's look at one last more theorem. It says, if my function is integrable and non-negative on a closed interval, then the integral from a to b fx ds is greater than or equal to 0. Remember, integral is nothing but area under the curve. Your area can be either 0, but area can never be negative. That's what basically it is talking about here. Now, other thing it says is if I have two integrable functions on a closed interval, and this function is always less than or equal to gx. In other words, suppose I have two functions, the gx is always bigger than the function fx. So if I want to take the area under these curves from a to b, so let's say I want to find the area from here, area from a to b. So clearly, the area under the function gx is definitely more than the area under the curve fx. And that's what it says. Now let's look at some of the examples which will help in terms of using our properties of integrals. Okay, now what are we given is, we are given the definite integrals for three different integrable functions, and we would like to apply them with the properties we just learned. Okay, the first integral which is given to us says 2 to 4 x cubed dx is 60, 2 to 4 x dx is 6, and 2 to 4 dx is 2. This is what is given to us. We would like to use these three to evaluate these four given integrals. Let's start with the first one. It says from 2 to 2 x cubed dx. Remember, when the lower integral is the same as the upper integral, automatically the answer is 0. Okay, next one. 2 to 4 minus 5x dx. Now remember, there's a constant multiplied. So formula says you can take the constant outside and just go ahead and take the integral of from 2 to 4 x dx. Now we already know that the integral from 2 to 4 x dx is 6. So what is the answer? Minus 5 times 6 minus 30. Okay, let's look at this. The next one. 2 to 4, 20 dx. Now 20 is a constant, guys, so take the 20 out and have 2 to 4 dx. This is the same as this integral which is given to us, which is a 2. So it's 20 times 2, answer is 40. Okay, the last one. 4 to 2x dx. Now remember, what are we given? We are given 2 to 4x dx. So what has happened is they have flipped the lower and the upper integrals. And we know the answer to that is it's the same as negative integral from 2 to 4x dx. So we just go to the appropriate integral value and plug it in. So it's minus 6. Okay, let's look at other examples. Now over here, we are given a definite integral from 0 to 5 fx dx to be 4 and integral from 5 to 8 fx dx to be minus 1. So it doesn't matter what the fx is. We just need to know the integral value. The question is, find the following. It says 5 to 5 fx dx. Oh, before I forget, let me tell you guys, till now we were doing problems where we knew what the functions were. But now what we're doing is we're generalizing it and say, hey, I don't care what the function is, I'm just giving you the value. That's what we're doing here. Okay, so coming back to the problem, you're given 0 to 5 fx dx to be 4 and 5 to 8 fx dx to be minus 1. The same rule of definite integrals will apply. So the first one is 5 to 5 fx dx. Clearly the lower and the upper integral are the same. Just put a 0. Then the next one says 5 to 8 minus 3 fx dx. The rule is take the constant out, 5 to 8 fx dx. What do you get? Minus 3. Now 5 to 8 fx dx is minus 1. It is 3. Now 8 to 5 fx dx. Now remember, we are flipping the lower and the upper integral. So it is negative of 5 to 8 fx dx, which is negative of negative 1, which is 2. Oh, sorry, 1. I'm not adding, it's just 1. Okay, now let's look at this now. 0 to 8 fx dx. Now we're not given 0 to 8, but what we're given is 0 to 5 and 5 to 8. So we will apply the additive property of integrals. So here what are you going to write? 0 to 5 fx dx plus 5 to 8 fx dx. Now 0 to 5 fx dx is what? 4 and 5 to 8 minus 1. The final answer, 3. Let's look at another way of solving these definite integrals applying the rules. Now, we are given a definite integral from 2 to 6 fx dx to be minus 10 and another integral 2 to 6 gx dx. So we have two different functions, but they're giving us the integrals within that the intervals. Now, the first one is you want to find 2 to 6 fx gx. Basically, remember what is it? It is 2 to 6 f dx. I'm just trying to save here. 2 to 6 g dx. So, what is, and so it's fx dx. Remember that, guys. Just a shortage of space. I'm just writing f and g's. So 2 to 6 is what? Minus 10. And 2 to 6 is 2. So minus 10 plus 2, we get negative 8. Now here we have 2 to 6 gx minus fx. How are we going to write this one? We're going to write 2 to 6 g x dx. Now remember, minus is a constant. You can pull that out. 2 to 6 fx dx. Now, what's 2 to 6 gx dx? 2. Minus, and what is 2 to 6 fx dx? Minus 10. So the answer is 12. Let's look at the next one. 2 to 6, 2 times fx dx. Now remember the formula, take the constant out, and you have 2 to 6 fx dx, which is 2 times minus 10, negative 20. Okay, the next one is 2fx minus gx dx. Now 2fx is already, we got the answer. Just going to write this one down. Different marker here. So it's 2 to 6, 2fx dx minus 2 to 6 gx dx. Oh, that was a mistake, guys. We haven't learned this one. So please remove this one. I did not see that. Okay. So 2 to 6 is already, the answer is negative 20. And negative this 2 to 6 is negative. Where is it? Negative 2. So the final answer, negative 22. Okay, so cancel the other questions because I have not done that property with you guys. So and that's integral property. So it's not, this is not the correct one. So please remove it. Okay. What I really want you to work on is the practice problems. I want you to work on these problems on slide number 20, then slide number 21, 22, 23, and 24. All these problems, guys, are based upon the problems I have done earlier in the session. Thank you.